Hello again, Mr. Dodd back, working through the graphing unit of pre-calculus. Today we're going to talk about piecewise functions. Basically, these are graphs that are split up, where I'm going to give you 3 equations, or 2 equations, or 5 equations, or whatever, as you can see on the bottom of the graph here. And then I'm going to give you different x values where those functions are graphed. So my suggestion, there's lots of different ways to go about this, but my suggestion is to split the graph into sections and then plug the values in for those transition points. So on this first one, it'd be -1 and 2. It'd be -2 and 2 on the second one, but plug those values in and that'll give you an idea of what's happening at the transition point. You're going to add those to the graph. We'll use open and closed dots, whether it's included or not included. So, for example, on this one, x is less than -1 means I need an open dot for this particular graph at its endpoint. And then I'm going to connect the points with the graph of the line in each section. Okay. So what does that look like? If you want to take a stab at it, awesome. Good time to pause the video, try it out, and then I will work through these. If not, you can just wait and see the first one, maybe pause after this one. Anyway, basically, so step 1 is I'm going to split my graph up. So I'm just going to put a dotted line here, and this is going to be essentially my wall. And what this is saying is x minus 2 is going to be graphed where x is less than -1. So I'm only going to graph x minus 2 in this first section right here. Okay. Between -1 and +2, that's my other section, I'm going to graph the line y equals x squared minus 1, x squared minus 1. So that's going to be graphed there. And then the last one is only going to be graphed to the right of the line x equals 2, -1/2 x plus 4. All right, so this is how it goes. Basically, if I plug in a point, if I plug in the point -1, -1 minus 2 is 3 in this first equation. So I'm going to go to the point -1, -3, and I'm going to put an open dot because that is a less than sign. All right? And then this line is just a regular line with a slope of +1. But normally we would go up 1 over 1 to find my slope of +1. But in this case, I can't do that because I am not allowed to graph this function in this middle section. So instead, I'm going to go down 1, left 1 to put my next dot and my next dot. Okay. So I would draw my arrow that way. And that one's just going to keep going forever and ever to the left. All right, next one. If I plug in my endpoint, -1 squared is 1, and 1 minus 1 is 0. That should be a solid dot because this is a less than or equal to. Okay, and then if I plug in 2 squared minus 1 is 3. So I'm going to go to the point 2, 3, and I'm going to put an open dot because, again, there's no equal to piece there. All right. I maybe should have mentioned this from the beginning, but this comma just separates the equation from the section that is going to be graphed in. So then I know, well, this is a parabola, correct? It's a parabola with a vertex at 0, -1. So I'm going to graph my line. It'll go through this point right here, and then go up and connect with the open dot there. So I'm graphing just a section of the parabola, and that section happens to be from -1 to +2. And then I'm going to graph a section of this next line where x is greater than or equal to 2 off to the right. So that means I have a solid dot. If I plug in 2, that gives me -1 plus 4, which is actually 3. So that's actually going to turn this to a solid dot because I'm going to go down 1 over 2 from there. So those 2 points happened to be at the same spot, so I can fill that dot in and go from there. Again, good time to pause if you want to test out this second one on your own. If not, I'm just going to keep going, and we can go from there. So less than or equal to, my first wall is at -2. My second wall is at +2. Okay. So if I plug in my endpoint, negative 2 squared is positive 4, but a negative positive 4 is a negative 4. Negative 4 plus 3 is negative 1. That should be an open dot. Okay. Normally, this would be an upside down parabola starting from 3. So it would be something along this line, but I can't actually graph it in the middle. So I'm just going to see like that little curvy part of it on this. Now, if I plug in negative 2 to this function, negative 2 minus 1 is negative 3. So I'm going to have a solid dot at negative 3. If I plug in 2, I would get 1. So I'm going to have an open dot at the point 2, 1. And then the nice thing about this one is all I have to do is connect the dots because it's a straight line. And as long as you have 2 points, you can make a straight line. The third one, if I plug in 2, I would get negative 4 plus 6, which is positive 2. So a solid dot at positive 2. And then because it's a slope of negative 2, I'm going to go down 2, right 1, down 2, right 1, and I will connect the dots. Okay, so that is how we graph piecewise functions. This one takes a little bit of time to kind of theoretically understand, but once you understand, you have 3 different functions that you're going to graph along certain x values. It is pretty straightforward once you get that. Hopefully that's helpful, and good luck with this section.